Hey everyone, welcome to the Solidity Smart Contracts and Web3 crash course on codedamn. In this video, we'll be taking a peek into this course which we have on the main website, Learn Solidity and get started with Web3 and blockchain. So please feel free to enjoy this course, sit back and learn about how Web3 works, how you can get started with blockchain and Solidity in this video. And if you like this, then watch this video till the end. I have a special discount. I have a special offer for all of those who watch this video until the end. Let's go. If you're new here, make sure you leave a like, subscribe to the channel and hit the bell icon. This is free of cost and helps the channel grow.
Hi, my name is Kshitij Srivastava and I will be your instructor for this course. Now let me give you an overview of this course, what we are going to see. So first of all, we are going to have an overview about blockchain technology, then about Ethereum technology, and then we are going to switch to our main topic, that is Solidity. So now let us see what we are going to learn in Solidity. In this Solidity course, we are going to cover everything from basic to advanced level. So we are going to start with Solidity compilation process, because Solidity compilation is very much different from any other programming language. So we need to understand this. So we are going to start with this compilation process. Then we are going to talk about deployment environments, and do not worry about these technical terms, about the jargons, because we are going to cover everything in this course. Okay. So we are going to talk about that, then about its variables, then functions, which are actually the heart of our Solidity smart contracts, then data types, like all the data types like bool data type, integer data type, string data type, arrays, everything we are going to cover in this course. About its conditional statement, if, else, loops, global variables, and from this we are going to see some advanced Solidity concepts such as inheritance, abstract contracts, interface, and many other advanced topics. And after this, we are going to cover three major projects in Solidity, that is our e-commerce smart contract, then ERC20 token, and how to launch an ICO. So whatever you are going to learn in this Solidity course, you are going to apply them on these three major projects. And on top of that, we are going to have many labs, quizzes, so that whatever video you are watching, then you are practicing them in those labs and quizzes. So this is the full-fledged course to make you a master in Solidity. See you soon in the course. Hello guys, welcome back. Now we are going to study about what is blockchain. Now this is how a blockchain looks like. It is having a number of blocks, and all these blocks are connected with each other. Now what is the definition of blockchain? So if I have to define blockchain is nothing but it is a distributed immutable ledger. Yes, it is a distributed immutable ledger. And we are going to see the meaning of all these keywords one by one from right to left. First, we will understand what is the meaning of ledger, then what is the meaning of immutable, and then what is the meaning of distributed. So let's see what is the meaning of ledger. So what is a ledger? So you can think of ledger as a place where transactions are recorded. For example, when you go to McDonald's, right, you buy something, and when you buy something and you pay them, you might see them that they are typing something on their computer, right? They are typing something on the computer, like how much money they are like giving you as a change, how much money they are taking from you when you buy a burger or something. So all these things are actually being recorded on their system, or what I can say, a ledger. So a ledger is a place where transactions are being recorded. Any credit entry or any debit entry is actually mentioned in the ledger. Now this ledger in a non-blockchain world where blockchain does not exist can be in a form of a physical book or like a copy, or it can be in a form of a central database. Both of these things are used to record transactions. Any debit entry, any credit entry are being recorded in it. So these are the two things that are actually used to record transactions. Either it can be a copy, or you can think of it as a register or a central database. But in a blockchain world, when we talk about a blockchain world, in a blockchain world, the block of the blockchain is used as a ledger, because all the transactions are actually being recorded on this particular block. Now that's why we mentioned the keyword ledger. Now what is the difference between these two ledgers? The main difference between these two ledgers is that this ledger that you are seeing, that blockchain block, is actually immutable. By immutable, I mean that any transaction that is mentioned here or any transaction that is recorded here cannot be tampered with it. But if a transaction is recorded on a central database or on a ledger, it can be tampered. Any central authority, any person who is in the charge of these two ledgers can actually tampered with the database or the transactions. So this is the power of blockchain. Blockchain is completely immutable. Any transaction that is recorded on this particular block of the blockchain cannot be tampered with, cannot be changed. Now let's see the last keyword, that is distributed. We have cleared two keywords, right? What is a ledger? Then we have seen what is immutable. Now we are going to see why a blockchain is called distributed. Now the reason why blockchain is distributed is that the blockchain is actually distributed all over the network, which looks something like this. Now this is a peer-to-peer network or a P2P network, and if you will see, all the hosts, or you can say as nodes of this particular network, are carrying the same copy or exact copy of the blockchain. Each and every node in this particular network is carrying the same or exact copy of the blockchain. It is like A is having a particular ledger, or A is maintaining a ledger, and A is distributing this ledger to all the participants that are the part of this particular network. Now that's why blockchain is distributed. Now how this distribution takes place, let's see with the help of an example. Now let's consider here A is a miner. Now who is a miner? A miner is a person who actually mines a particular block and creates a block. So let's consider A is a person or a miner who is actually mining a particular block, and he is the first person who mines a particular block. So he added a block in his blockchain, and once he added a block in his blockchain, he transferred this information to all the participants or to all the nodes that are connected with him in the network. And after being verifying and validating this particular block, EFCB also add this particular block in their blockchain. So this is how the block of the blockchain get distributed all over the network, and that's why blockchain is distributed. So I think at the end of this video, you are very much clear with why blockchain is called distributed immutable ledger. Distributed because, as you can see, the blockchain is distributed all over the network. Immutable because once the data or any transaction is written on a block of the blockchain, nobody can tamper with it. And ledger because this particular block is acting as a ledger in a blockchain world. So meet you soon in the next video. Now we are going to talk about a very important topic, that is Ethereum. Before discussing about Ethereum, let's talk about the founder of Ethereum, who is Vitalik Buterin. Vitalik proposed the idea of Ethereum way back in 2013. Yes, he proposed the idea of Ethereum way back in 2013 when he was only 19 years old. The idea of Vitalik was very simple. He wanted to run programs on the top of a blockchain. Yes, he wanted to run programs on the top of a blockchain. If you will see the Bitcoin blockchain, it looks something like this. It has transactions running on it. So Bitcoin is mainly used for transactions, and that's what we do with Bitcoin, right? We transact. It is only used as a cryptocurrency, right? But if you will see Ethereum blockchain, it looks something like this. So apart from transactions, it also has programs. Now this gives power to Ethereum. This is the beauty of Ethereum, and that's why Ethereum is so powerful. Programs running on top of a blockchain. Now this opened the door for decentralized application. And what are these decentralized application? We have a separate video for it, so don't worry about it. We will be discussing about decentralized application in depth. And since we are talking about so many terminologies, right? Ethereum, Bitcoin, blockchain. So let's clear with all of them, like how these terminologies differ from each other, so that we are not confused and mixed up in our thoughts. Like when I'm saying Ethereum, you are thinking something else, and when I'm saying Bitcoin, you are thinking something else. So let's clear with all these terminologies when we are talking about this cryptocurrency world. So in our cryptocurrency world, mainly there are three layers. One is technology, another is protocol or coins, and the third one is tokens. Now what is this technology? This technology is nothing but it is blockchain, and we studied about blockchain in our first video, right? Blockchain is nothing but it is a distributed immutable ledger. So what are these protocols? These protocols are nothing but these protocols are Ethereum, Bitcoin, Wave, Neo. And with these protocols, we have coins associated with them. Like for Ethereum, we have Ether. For Bitcoin, we have Bitcoin. For Wave, we have Waves. And for Neo, we have Neo, right? Now, how this technology and protocol differ? Like we know that blockchain is a distributed immutable ledger, but how it differs from these particular protocol or coins, right? Basically, these protocols are nothing but these are the rules. Like we have HTTP, which decide like how the clients and server will interact, how the file transfer will take place. Like we have TCP/IP, right? In the same way, we have Ethereum, Bitcoin, Wave, Neo, and so many other protocols when we are talking about blockchain. Now, these protocols governs rules like what will be the consensus algorithm they are going to follow, how much amount of cryptocurrency will be given as a reward to a miner who mines a particular block. So all these things are actually governed by these protocols, and for all these protocols, rules differ, as Ethereum has a different set of rules, Bitcoin has a different set of rules, Wave, Neo has different set of rules. Now, what are these tokens? So these protocols mainly provide us with certain amount of tokens. Like Ethereum provide us with TRX, SNT, REP, AE. Bitcoin does not have any token. Wave has WGT, B1, WCT, INTL, Neo, DBC, TKY, ONT, TNC. Now, what are the use of these tokens? Now, these tokens are mainly used in ICOs. If you have heard the name of ICOs means initial coin offering. So when we talk about ICOs, we mainly talk about tokens. And people get confused between protocol and tokens. Like people who are actually into trading of cryptocurrencies, they also don't know the difference between protocol and token. They're investing without understanding that protocols, or what should I say, coin and tokens are different things. So let's see this practical demonstration on a website called coinmarketcap.com, where we will see how this protocol and tokens are differently listed on this coinmarketcap.com website. So this is our website, CoinMarketCap, and here if you'll see, all the cryptocurrencies are listed down here, and this website is mainly used for cryptocurrency trading, and all these fields like name, price, market cap, volume, all these things are in a very good way presented here, and you can also see this. And the most important thing to note down here is that if you will see all these things, that here all these things are a mixture of token as well as protocol. That's why you will see that here cryptocurrency tab is highlighted with blue, because it is showing all the cryptocurrencies. But let's filter them out. Let's filter them out one by one as tokens and as protocols. Okay, so let's use the option called filter. Where's the option called filter? Here it is. So let's filter them out. Okay, and here if you will see, we have all cryptocurrencies, right? And if you will click on this, you will see that these cryptocurrencies are mainly a mixture of coins and tokens. So let's see the tokens first of all, and then we will see the token. So let's see the coins first of all, and then we will see the tokens. Now, all these things, Bitcoin, Ethereum, as I said, these are protocols or coins, and all these things are listed here, right? And let's filter them out by tokens. Okay, let's use the option called filter, like tokens, and show results. So now you can see there are different set of things, right? Tether, USD coin, Uniswap, Binance USD. So all these things that you are seeing on your screen are mainly tokens, which are mainly used in ICOs. So I hope now you are very much clear with these terminologies, right? When I'm talking about blockchain, I'm talking about distributed immutable ledger. When I'm talking about Ethereum, Bitcoin, Wave, Neo, Ripple, or any other protocol, so mainly these are protocols or coins. And tokens are generated with the help of these protocols only. So I think now all these confusion regarding all these terminologies are very much clear. Now we are going to talk about a very important topic, that is Ethereum account. Now, what is this Ethereum account? So let us understand this Ethereum account with the help of bank account. Okay. So why we need bank account? We need bank account so that we can transfer money and receive money. And there are other sort of things also, but mainly we need a bank account so that we can send and receive money, right? When we talk about Ethereum, we also need Ethereum account. Now, why we need this Ethereum account? So that we can transact in terms of Ether, so that we can send and receive Ether. That is what Ethereum account is. So Ethereum account is an entity through which you can send or receive Ether. So this is what Ethereum account is. Basically, there are two types of Ethereum account. First is externally owned account, that is actually managed by humans. And then another type of account is contract account, which is actually managed by the code of the contract, that is the smart contract manage this particular contract account. So how we create this EOA, that is how we create this externally owned account. This externally owned account is created whenever we create a wallet. So this wallet can be any wallet. Maybe it can be a MetaMask wallet, it can be a MyEther wallet, it can be any wallet. And if you are not familiar with these terms like MetaMask, MyEther wallet, Don't worry, we are going to cover this in depth in our upcoming section. So with the help of wallet, we can create our Ethereum account. So it is just like bank, right? Whenever we go to a particular bank, we can open an account. The bank can be any bank, but we can open an account there, right? In the same way, whenever we create any wallet, either MetaMask, MyEther wallet, we are actually creating an Ethereum account. Now, and why we need this wallet? We need this wallet so that we can send Ether, receive Ether, plus we can interact with other smart contract. And this wallet also helps us to see our account balance, like how much balance of Ether do we have in our account. So all these functionalities can be performed with the help of your wallet. But to access your wallet, you need a special thing called a private key. So this private key is just like a password to your wallet, with the help of which you can only access your wallet and nobody else can access your wallet. So this private key is just a password to your wallet. So now let's see what is a contract account. A contract account is created whenever we deploy a smart contract on our Ethereum block or our Ethereum blockchain. So whenever we deploy our smart contract on our Ethereum blockchain, a contract account is created. And with the help of this contract account, again, we can send Ether, receive Ether, and interact with other smart contracts. So this is the power of contract account. Now, to have a better understanding, let's see a practical demonstration, or should I say an example, how this Ethereum account and this contract account looks like. So now let's see how this exchange owned account or our MetaMask wallet looks like. So this is my MetaMask wallet. Okay, so this is my MetaMask wallet, and here you are seeing my Ether balance. And don't worry, this is not real Ether. I'm not that rich. This is a fake Ether. Yeah, this is fake Ether. And if you will see, we have both the option buy as well as send, right? So we can buy as well as send Ether, and we can also interact with our smart contract with this network tab. And we will be covering all this in depth. We will be deploying our smart contract on one of these networks. So all these things are coming up. So don't worry, we will be covering everything in detail, how to like install this MetaMask and how to do all these things. And this is the address of my Ethereum account. So because as we go to our bank, right, and when we go to a bank provides us with a bank account number, right, so that we can access our bank account, we need an address, right? In the same way, for Ethereum account, we have a address. And let me copy this and paste it here. Okay, I have already pasted here. So this is my actually Ethereum account address. This is my Ethereum account address, and with the help of this Ethereum account address, I can access my Ethereum account. Just like my bank account number helped me to access my bank account, in the same way I need this Ethereum account address so that I can access my Ethereum account. So let's see our contract account and how that looks like. So this is our contract account address. So this is how it looks. So like our exchange owned account, our contract account is also having a unique address. The reasoning being the same, that to need or to access a particular account, we need an address, and this is how contract account address looks like. And we will be covering this contract account in detail when we are going to talk about our Solidity project. In that, I will be talking you how to send or to receive Ether to our contract account, because contract account is mainly handled by the code or by the smart contract, right? So when we are going to code our smart contract, then I will be explaining you all these things in very great detail. So for now, don't worry, what is this contract account? If you are not understanding for now, like how do we do that, or how all the steps, like how all this works, don't worry, for contract account, I will be explaining you each and everything in detail when we are going to cover our Solidity project. So don't worry for now. So let's see the differences between externally owned account and our contract account. As we have seen earlier, that for externally owned account, we need a private key, right, to access the wallet. But for our contract account, we do not need any type of private key or public key, any sort of things to access our contract account. When we talk about our externally owned account, these are mainly controlled by humans, and that's why we need a private key, right, in the first place. But since these contract accounts are mainly controlled by the code of the smart contract, so we do not need any private key or public key. The code do everything. So like code is the one who is actually looking for this contract account. When we talk about our externally owned account, we do not require any type of gas. Like what is this gas? For now, you can think of it as a currency that we have to pay to open any Ethereum account. But gas is something different, and we will be talking about this in our upcoming videos, so don't worry. But when we talk about our contract account, we need a certain amount of gas. So think like when we are actually opening a contract account, we have to pay a certain amount of fees. You can think like that, because we are deploying our smart contract on our Ethereum blockchain. So we are actually occupying certain amount of space, right? So we have to pay a certain amount of fee in terms of gas, and that's why we need a gas to open this contract account. When we talk about our exchange node account, our exchange node account has a unique address, right? And we have seen that also. And why we need a unique address? So that we can access our externally owned account or our Ethereum account. In the same way, for our contract account, we also need a unique address so that we can access our contract account. And when we talk about external account, it can hold ETH balance, and we have seen that our wallet is holding a certain amount of Ether balance, right? In the same way, our contract account can also hold our ETH balance. Yes, our contract account can also hold certain amount of ETH balance. Now we are going to talk about a very important topic, that is smart contract. So what is this smart contract? So a smart contract is nothing but it is a program that runs on Ethereum blockchain. Yes, it is a program that runs on Ethereum blockchain. So the question arises, why do we call it as a smart contract if it is just a program? And the reason for this is very simple. To understand this better, we have to understand what is a contract. So a contract is nothing but it is an agreement between two or more parties where the parties involved in the contract have to fulfill certain legal obligation. For example, if two parties such as A and B are involved in a particular contract, then A has to do certain things and B has to do certain things so that the contract is successful. And we will be seeing this with the help of an example, so don't worry. And why do we call it as smart contract? We call it as smart contract because the program that we are writing on Ethereum blockchain is acting as a contract, and since this program is in a digital form, or this contract is in a digital form, that's why we call it as a smart contract. So let's see this with the help of an example so that we understand this in a better way. So let's say that there are two people, A and B, where A is a distributor of fruit and B has a shop who sells fruit. And A and B are in a business where A delivers fruits to B and B then provide A with a certain amount of money according to the fruit delivered by A. But what will happen if the fruit delivered by A to B are not in a good condition? If the fruit delivered by A to B are not in a good condition, then B will be having a large amount of loss because the fruit delivered by A are the one that B used to sell to his customer. Now, in this particular case, B will be having a large amount of loss. Now, how and what B can do to prevent from this loss? Now, to prevent from this particular situation, A and B can enter into a smart contract so that B does not suffer this amount of loss or this huge amount of loss. So now let us see the whole process of this smart contract. So A and B will be entering into an agreement, and in this agreement, every rules and regulation will be written in the form of a program or in the form of a code. And what will be written in this contract, we will be seeing this in our upcoming slides. And then B will be sending a certain amount of Ether to this contract. And where this Ether will be sent? So this Ether will be sent to the contract account. And we have studied about contract account. And in that lecture, I also told you that we will be discussing about the application of contract account, right, in our smart contract. So this is why we need a contract account. Here, B will be transferring a certain amount of Ether to the contract account. And for transferring this Ether, B will be using a contract address so that he can send this Ether to this contract account. Now, why B is doing this? We will be understanding this in our upcoming slides, so don't worry about it. And if this contract is successful, then from this contract account, Ether will be transferred to A. Yes, so this Ether is the same Ether that is transferred by B to this contract account, and from this contract account, Ether will be transferred to A if this contract is successful. And if this contract is not successful, definitely this Ether will not be transferred to A. So now let us see what is written in this particular contract so that we can understand how this contract actually works. So now let us see what is actually written in this smart contract, which is formed between A and B. And here, if you will see, I have written a note that optimum temperature to maintain fruit is less than 30 degrees Celsius. So what do I mean by that? So what actually A is going to do is, A is going to install a sensor to this container in which actually the fruits are kept. So actually, we are assuming that this container is a refrigerated container. And if the temperature of this container is less than 30 degrees Celsius, then the fruits would be fresh. Otherwise, fruits will get rotten. So if the temperature is less than 30 degrees Celsius, then the fruits will be fresh. Otherwise, they will get rotten. And I am not a fruit seller, so I do not know whether it is 30 degrees Celsius or any other temperature. What we are doing is just an assumption. We are taking that 30 degrees Celsius, less than 30 degrees Celsius is an optimal temperature to have fresh fruits. Okay, so this is just an assumption. And yes, there can be other factors which are also responsible to have these fruits as fresh, but we are not going to take those parameters. We are only going to take temperature as a parameter, which is mainly responsible to have fresh fruit. Okay, so we are only going to take one parameter, that is temperature, to have fresh fruit. If the temperature is less than 30 degrees Celsius, we are going to have fresh fruit. Otherwise, we are going to have rotten fruit. Okay, to make this example simple, that's why I have taken one parameter. So now let us see what is actually written in this smart contract. So, and we are going to use a flow diagram to understand this better. So if the smart contract detected a temperature greater than 30 degrees Celsius, okay, if sensor that A has installed to his truck, that the container of his truck, if the sensor detected a temperature greater than 30 degrees Celsius, in that case, the contract will not be paying anything to A, right? And we have seen this in our previous slide that contract is the one who is actually going to pay to A, right? And if this condition is true, means if the temperature is greater than 30 degrees Celsius, then the contract will not going to pay to, like, contract will not be paying to A any amount, any ether will not be paid to A, because fruit will not be fresh at this temperature, because the temperature is greater than 30 degrees Celsius, and we have assumed that the optimum temperature to maintain fruits is less than 30 degrees Celsius. Okay, and if this condition is false, in that case only we are going to pay A. Yes, in that case only we are going to pay A. So if you will see, this contract is the main thing which is actually going to pay to A or will not going to pay to A, depending on the situation. If this condition is true, then definitely contract will not pay to A, and if this condition is false, then the contract will be paying to A. Yes, the contract has to pay to A because the code is written in that particular way only. You might be wondering, like, this is so easy, right? We are just writing a simple code and this is how it works. Yes, this is easy because, as I said, smart contract is nothing but it is a program, right? So this is how a program is written: if and else conditions. So we have certain if and else blocks, and this is how we write a smart contract. Now, what is the beautiful thing about this smart contract? So the most beautiful thing about this smart contract is that this smart contract is actually getting deployed to our Ethereum blockchain. And what is the property of blockchain, or what is a blockchain? A blockchain is a distributed immutable ledger. Okay, so this smart contract, first, this smart contract will be distributed. Second, it will be immutable. Yes, it will be immutable means nobody can tamper with this smart contract or with this program. Once it is deployed on the Ethereum blockchain, nobody can change this smart contract. Now, this smart contract is the main, like, this is the, you can think of it as a main executioner. Now, this smart contract is the main thing which is actually going to establish trust between A and B, and this smart contract will be the one which will help B to not to get into a loss, because this smart contract, as you see on your screen, has condition like this, that only A will be get paid when A is going to deliver a fresh fruits. If A is not going to deliver fresh fruits, A will not be get paid. So I hope you have understand what is this smart contract. I hope you also understand why we need contract address and contract account. So what are decentralized applications? If we talk about the definition of decentralized applications are applications that run on a decentralized network. So any application that is running on a decentralized network is actually a decentralized application. But what do I mean by that, right? So you will understand this with the help of an example. We will be comparing our centralized application with our decentralized application so that we can understand how these two applications differ and what is actually decentralized application. So if we see the model where client server, or sorry, our centralized application run is a client server model. So this is our client server model. For example, YouTube is a centralized application, right? So when we request any video or any data, we are actually requesting all these data from the YouTube server. So this is our YouTube server and this is our YouTube application. So if we request any data or any video or something like that, we are actually requesting from YouTube server that we need a particular data, and YouTube server is actually providing us with that data. So we are actually the clients connected with the server. But when we are talking about a decentralized application, in a decentralized application, there is no client server model. Decentralized application actually uses a P2P network. And if we talk about this P2P network, our decentralized application is actually running on all the nodes that are connected to this particular network. We are considering it as an Ethereum network, and in our Ethereum network we generally call these system as nodes. So all these nodes, if you will see, the application is running on all the nodes that is the part of this particular Ethereum network or this particular decentralized network. So this is how decentralized application run. And how a decentralized application is created. So a decentralized application is created with the help of our front end. Then we integrate this front end with the smart contract, and then we actually make our decentralized application. Now, what is this front end? So this front end can be anything, like we can use any front end language, for example, React, JS, HTML, and CSS, and then we integrate this front end with our smart contract. And this is how we make our decentralized application. So the human interaction, like to make human interaction easy, we need a front end, and all the logics that we have seen in our previous example, right? How we create a smart contract. So all our logics is actually present in this smart contract, and all the human interaction to make human interaction easy with our application, we use a front end. And when we deploy this front end plus our smart contract on our decentralized network, we are actually making our decentralized application. Now, this is wonderful, right? Now we are making an application that is running on a decentralized network, and decentralized application is formed. So let's see a real life decentralized application so that we can understand it in a better way. Now, this YouTube is actually a decentralized application. Like YouTube is a centralized application that is help us to run YouTube videos, right? Where we can see videos in the same way if you are seeing on my screen. Actually, this DTube is one of our decentralized applications, which is just like our YouTube. Yeah, it is cool, right? Now this is our decentralized application that is actually running. Now definitely it is not very much developed, but still, if you will see, like there are certain videos also uploaded on our decentralized application. Let me try one of these. I haven't tried any of these before, so let me try. Okay, so it is actually working, right? And definitely there are less views and all those things, and reason is very simple, because still we are using our centralized application. But yeah, in our coming time, I believe we are going to use this decentralized application in a much better way. Now, these are some of other examples of decentralized application. Like for search engine, we have Google, and for decentralized, in our decentralized application, we have pre-search. For social media, we use Twitter, right? In the same way, we have LBRY. Please do check them out, right? I believe that you will learn a lot by seeing all these decentralized applications, like how these decentralized applications work, how these looks. I was amazed when I saw them first, but you can also see them and you will finding very interesting things. There are various other decentralized applications already built, and we are seeing only some of them. Like for video platform, we have seen YouTube as a centralized application, right? But we have seen YouTube is the same as YouTube. Definitely it is not developed as much as YouTube, but in the coming time, I think we are going to see all these decentralized application much more advanced than and much more used as compared to our centralized application. Let's hope that. So now let us see the differences between our centralized application and our decentralized application, so that in a better we can get how this centralized application and decentralized application works. Now, when we are talking about our centralized application, these centralized application are not trustworthy. Yeah, definitely they are not trustworthy, because centralized application, the main issue with centralized application is that whatever they say, they never do, right? They are actually taking our data, and they are saying that we are not taking your data and everything. Like Facebook, for YouTube, Google, they say that we are not using or misusing your data, but we do not know, right, what code they have written, right? But when we are talking about a decentralized application, mainly decentralized application, source code is available to public. Yes, since most of the time the source code is available to public, we can easily check that how this decentralized application work, what is the code written, and how these, if they are collecting our data, so how these are using our data. So everything is, since it is in a open source or in a it is public, we can easily see and check them out. But when we talk about when we talk about a centralized application, no source code is available, so we cannot check like how they are using our data or what they are actually doing with our data. When we are talking about our centralized application, like, so mainly they censorship, like censorship in the sense that most of the time, if you see, like most of the applications censor the data. If certain type of riot or something like this is happening in some part of country, so what they do, they censor the data so that normal people cannot watch what is actually going on. But when we talk about a decentralized application, no censorship is possible. So everything is transparent. But in centralized application, transparency is the major issue. So transparency is not there in our centralized application. But when we talk about a decentralized application, there is no censorship. when we talk about our centralized application, we actually pay them to use them, right? For example, if we talk about YouTube, so we are actually paying through our attention. When we pay our attention to YouTube, YouTube shows us with ad, and that's how YouTube collects revenue, right? But when we talk about our decentralized application, they actually pay us. Yes, they actually pay us in the form of a cryptocurrency. When you are watching any ad, or when you are like watching or scrolling any blog, so those blogs, those ads are actually paying you in terms of cryptocurrency, and now you are getting rich by actually using your attention for something that you want to see, and you are actually getting paid for that. So this is how I call, like, this is amazing, right? This is amazing. You are going to get rich by watching decentralized application ads and something like this, right? But when we talk about us this centralized application, they can go down. Yes, all these centralized application can go down, means their server can go down because there is only a single server, like we have seen in our previous slides, right? We have a single server and an application is running on that server. But the thing with decentralized application is they can never go down, since our application is running on so many thousands of nodes, right? Since our decentralized application is running on thousands of nodes, there is no chance that decentralized application will ever go down until or unless all those nodes are destroyed. So this is the beauty of decentralized application, and all this beauty is just because decentralized application is actually using blockchain, because blockchain is distributed, so it is present everywhere. It is immutable, so nobody can ever tamper with it. So that's why that's why decentralized application, I believe, are more effective than centralized application. Hello guys, welcome back. Now we are going to talk about a very important topic, that is Ethereum virtual machine, or EVM. Now before talking about this Ethereum virtual machine or EVM, let's recall our knowledge of our decentralized application that we have seen in our previous video. Now what is a decentralized application? A decentralized application is an application that runs on all our system, right? That's why it is called decentralized. Now, if this is a Ethereum network, then this decentralized application will be running on each and every node that is connected to this particular network, right? Now, the problem with this is decentralized application are nothing but programs, right? And programs are executable codes. Now, what will happen? What will happen if this executable code is a virus? What if a hacker write a virus and deployed that virus on all our system? Since viruses are nothing but executable code, or should I say a decentralized application in this particular case, that virus will be running on all our system. Now this is a very dangerous situation, because this virus can not only harm your system, but can be an intrusion to your privacy. This can also ask for some ransomware, or this virus can be a Trojan virus, something like that. Now this is a dangerous situation, right? Now how can we prevent this particular situation? Because if this virus is executed on our code, then there will be a lot of loss on all the nodes that are connected to this particular Ethereum network. Now to prevent from this particular situation, what we install is our Ethereum virtual machine. Now what is this Ethereum virtual machine? So instead of running decentralized application directly on our system, right? Instead of running this decentralized application directly on our system, what we do, we install a Ethereum virtual machine on our system. And we run this decentralized application on top of our Ethereum virtual machine, not on our system. So when decentralized application run on our Ethereum virtual machine, it cannot harm our system in any way. So it cannot touch our hardware or something like that. So your system is totally safe. Now this is the power of Ethereum virtual machine. Now how this is possible? So you can think of it by an example of VirtualBox. Like when we install VirtualBox, like VirtualBox is a software through which you can run a different operating system on your host operating system. For example, if you are using Windows, you can run Linux as an operating system on top of Windows with the help of VirtualBox. So this situation is something like this. You are running a system or a computer inside your computer. Now this is the beauty of Ethereum virtual machine, isn't it? Now this decentralized application can do harm. Any harm will be happening to your Ethereum virtual machine and not on your system. So this is what Ethereum virtual machine is, and that's why this Ethereum virtual machine is very important. So what is this Ethereum Gas? We first heard this name when we were talking about our exchange owned account and our contract account, right? When I was talking about the differences between our exchange owned account and our contract account, then I used the term gas, in which I told that for exchange owned account, you need not to pay any amount of gas. But when we talk about our contract account, then we have to pay a certain amount of gas. Now, what is this gas? We are going to see in this video. Now, let us understand what is this Ethereum gas with the help of an example. And in this example, we are going to use a car. Yes, we are going to use a car. Let's say you have this beautiful car, okay, and your car is standing at point A. Okay, your car is standing at point A, and from point A you want to travel to a point B. So your car is standing at point A and you want to go to a point B. Now, for your car to travel from point A to point B, you need something to so that your car can operate, so that your car can start. And what is that thing? Now, that thing is nothing but petrol or gas. Now, when you have this gas in your car, then only you can travel from point A to point B. In the same way, whenever we deploy our smart contract on an Ethereum blockchain, we need gas. And that gas is not petrol, but that gas is actually Ethereum gas. With the help of this Ethereum gas, we can deploy our smart contract on Ethereum block. And why do we need this gas? We need this gas because when we write our smart contract, we have certain amount of operations like addition, multiplication, subtraction, and all those operations cost you a certain amount of gas, and which we are going to see with the help of example. So let's see what is an example and why do we need this Ethereum gas. So let's say you have written a very beautiful smart contract, and in that smart contract you are evaluating an expression which looks something like this, which is 5 into 2 minus 1, and you want to evaluate this expression. Now, to evaluate this expression, you need gas, and where this gas will be needed to perform operations such as multiplication, subtraction, and equal to. All these operations that you are using to evaluate this expression will actually cost you a certain amount of gas. And every mathematical operation that I am using here has a different usage of gas. Like for example, multiplication will need 5 gas, subtraction will need 3 gas, while your equal to operator will need a 3 gas again. Now, how I know all this? We are going to see that in our upcoming slide, so don't worry about it. But for all these operations, we need certain amount of gas, as you can see on your screen. So if I have to calculate what is the total amount of gas that I will be needing to evaluate this expression, so that will be 5 plus 3 plus 3. Since we are using only one multiplication operator, one subtraction operator, and one equal to operator, that's why the total amount of gas that we will be needing to evaluate this expression will be 5 plus 3 plus 3, that is 11 gas. Now let's see how I got all these values, like how I got this multiplication as 5 gas, subtraction will be needing as 3 gas, and equal to will be needing as 3 gas. So let's see to our website where all this is given. So this is the website where every information about all the operators and their gas associated is given. And if you will click on this and then on this, you will be seeing all these operators and the gas that they require. That first off, we need 0 amount of gas, add, 3, multiplication, division. So all these gas is given for each operator. And definitely we are going to use all these operator like balance and all these when we are going to do our Solidity project and our Solidity programming. Then we will be seeing all these other opcodes that you might have not seen before, like timestamp, number, difficulty, everything will be covering in detail. And but for now, you can see this chart, and this chart is having all the values, all the gas was associated with all the opcodes or operator that we are using, that we are going to use or we are using in our smart contract. Now here are some of the important points that you need to remember. That is, first is any transaction that modifies the blockchain costs gas. Means any transactions for like we are going to cover transaction when we are going to talk about Solidity. For now, you can understand like any operation that modifies the blockchain will actually cost gas. So any operation that you are going to perform, and if it is going to modify the blockchain, then you have to pay a certain amount of gas. Now the second point is the user that generates the transaction pays for the gas. Yes, the user that is actually generating the transaction, like if you are, let's say you are paying your friend, or like you are sending ether to your friend, or doing any, like you are deploying the smart contract on Ethereum blockchain. So if you are performing any type of operation, like any transaction if you are doing, then you have to pay for that gas. So you are the one who is going to pay for the gas. So the user that generates the transaction pays for the gas. So I hope you have understand what is this Ethereum gas. Now we are going to talk about Ethereum gas price. So what is this Ethereum gas price? So in our previous video, we have taken an example of a car, right? That you have a car, and to travel from point A to point B, you need petrol in your car. Then only your car can travel from point A to point B, right? Now, let's assume that to travel from point A to point B, you need 10 liters of petrol. Okay, so you for traveling from point A to point B, you need 10 liters of petrol in your car. Okay, now if I ask you, what is the total amount of money you spent to travel from point A to point B? What answer you will give me? Like, what will be your answer if I will tell, okay, if I will ask you that how much amount of money you have spent to travel from point A to point B by using 10 liters of petrol? So what will be your answer? Confused, right? You will be thinking, okay, we do not know anything about petrol price, right? And without knowing the petrol price, how can I tell that how much money I have spent to travel from point A to point B? Okay, so let us assume again that the petrol prices, 1 liter petrol price is rupees 100. Okay, so if you are like outside India, you can think of it as $100, and if you are inside, like if you live in India, you might be knowing this is like rupees 100. Okay, so let us assume that for 1 liter petrol, you need rupees 100. Okay, rupees 100. So how much amount of money will be required to buy 10 liters of petrol? So your answer will be 10 into 100, right? Because for 1 liter, if it is 100 rupees, so for 10 liters, it will be 10 into 100, that is, or 100 into 10, that is 1000 rupees. So to travel from point A to point B, you spent total rupees 1000 rupees. You might be wondering why I'm taking all this thing, like what is this petrol and liters, cars, what it has to do with Ethereum gas price. Now I have taken this example so that I can make you like understand what is this Ethereum gas price. Now in a previous video, we have seen that to evaluate this expression, we need total 11 gas, right? Total 11 gas. So here, if you will see this gas is nothing but this is a unit, just like liter. Like in this, liter is a unit, right? And to know the price, to travel from point A to B, we need to know 1 liter of petrol cost. In the same way, to evaluate this expression, we need 11 gas. That's good. But if I ask you how much price do you pay to get this 11 gas, you cannot tell me, right? Unless I tell you how much amount a gas cost. Okay, so if I ask you like how much money did you spend to evaluate this expression, you cannot tell me, because as I said, gas is just a unit. It is not a currency, right? So now we are going to talk about Ethereum gas price. Now this is Ethereum gas price, which will help us to understand, or which will help us to evaluate the total price that we are going to spend if we are going to evaluate this expression. So what is this Ethereum gas price? So this Ethereum gas price, it is the total amount. It is the amount the sender wants to pay per unit of gas to get the transaction mined. Gas price is set by the sender. Now, what does this mean? It is a complicated sentence. If you are thinking it is a complicated sentence, let me make easy for you that it is simply per unit of gas to the transaction mined. Means the amount that you pay for per unit of gas. It is like the amount you pay for per unit of petrol. Okay, and this gas price is set by the sender. For example, and yeah, generally gas price is denoted in GUI. Now what is this GUI? GUI is a unit. Like we have ether, 1 ether, 2 ether, 3 ether, and in one GUI there are 10 to power minus 9 ether. So GUI is a unit which we use when we talk about ethers. So gas price is generally denoted in GUI, and you can set the gas price. Like for petrol, if you see, petrol price is set by the government, right? But we can set the price of gas. Like I can set the gas price to be 10 GUI. I can set the gas price to be 100 GUI. I can set the gas price to be 1000 GUI. Means this is under my control how much gas price I want to pay for. Like for per unit of gas, how much price I am willing to pay, I will decide. No one other will decide, no government will decide. This will be decided by me. So by assuming, let's assume that if we are going to pay one gas price as 10 GUI, means it is just like 1 liter of petrol cost you 10 rupees. So if I'm going to pay for one gas price, I'm going to pay 10 GUI. So if we talk about this expression, how much GUI we are going to totally spend? We are going to spend 11 into 10, right? 11 into 12 GUI, that is 110 GUI. Now another question might be like, okay, I got your point that we can set gas price. Okay, this is our choice. But why in the hell I will set gas price to be 1000 GUI if I can set it to 10 GUI or even 1 GUI? Like why I will set it to 1000 or even 10,000 GUI if this is under my control? And the answer to this is very simple. The higher the gas price, the faster the transaction will be mined. That's why we set gas price accordingly. So if we want our transaction to be getting mined fast, we have to set our gas price in such a way that our transaction will get mined fast. If we are going to set our gas price too low, in that particular scenario, the chances are either our transaction will never be mined or our transaction will take a lot of time to get mined. So for example, if you are sending, let's say 10 ether to your friend, okay, and you set the gas price, let's say to 10 gui, and if that 10 gui is too less at that particular situation, like considering the scenario, in that particular case, the chances are your friend will never receive that 10 ethers. Okay, so that's why we have to set the gas price accordingly. So the higher the gas price that you are going to set, the higher the way you are going to give, the less time it will take for your transaction to get. Ethereum gas limit. Ethereum gas limit is the maximum amount of gas that a transaction can consume, and it is set by the sender of the transaction. Means whosoever is doing the transaction has to set this Ethereum gas limit. For example, you are sending ether to your friend. In this particular case, you have to set an Ethereum gas limit because you are in this case doing a transaction. You are actually sending ether to your friend. So in this case, you have to set a Ethereum gas limit. And where do you set this Ethereum gas limit? You set this Ethereum gas limit in your wallet. Like for example, MetaMask. An Ethereum gas limit is also used to calculate the transaction fees. Since you are sending some ether to your friend, right? Now in this case, you are actually utilizing the Ethereum blockchain and Ethereum network, right? So you have to pay certain amount of fees in this particular case. You have to pay fees to the miner who is actually mining your transaction. So let's see how we can calculate the Ethereum transaction fees with the help of Ethereum gas limit. Now let us take an example when A has to send B 1 ether. So we have one person A who wants to send B 1 ether. So in this case, what will be the transaction fee? To calculate the transaction fee in this particular case, we will use a formula which is transaction fee is equal to Ethereum gas limit into base fee plus tip, where Ethereum gas limit in this particular case will be 21,000 units. This is a standard gas limit whenever you are sending some ether. Okay, so for whenever you are sending some ether, in that particular case, most of the time you will see 21,000 units as the gas limit. But for example, whenever you are deploying your contract or whenever you are doing some stuffs in your contract, in that particular case, you have to set the Ethereum gas limit according to your convenience. Because as I told you before, right, whenever we are performing some operation in our contract, all those operation cost us some gas, right? So in that particular case, you have to set the Ethereum gas limit according to the operation that you are trying to perform in your smart contract. Okay, but for sending some ether, in that particular case, most of the time, Ethereum gas limit is 21,000 units. Now let us calculate the transaction fees. Base fees. Now this base fees is something which is actually set by the network. Now this base fees is something which is actually set by the Ethereum network. So we do not have to do anything with it. It is actually set by the Ethereum network according to the supply and demand of ether. Okay. And then we have the tip. Now this tip is something which we have to give to the miner who is actually mining our transaction. Okay, now let us calculate the transaction fees because now we have our Ethereum gas limit, our base fees and tip. So the transaction fee in this particular case is 0.00231 ether. You also have to have 0.0231 ether in your transaction. Means in total you have to send 1 plus 0.00231 ether, that is 1.00231 ether. Okay, and we can check this on our MetaMask wallet also. So let's see. Now, before moving further, let me tell you these are all fake ethers. Okay, do not think these are real ethers. These are all fake ethers on Dapps test network. Okay, so now let me send some ether to one of my addresses. Okay, and let me try to send 0.1 ether. Okay, now let me click on next. Now you will see that we have 0.1 ether. Okay, 0.1 ether and some amount of fees associated with it, right? It is 0.000032 ether, and we can also edit it from here. Like as I told you, right, we can set the gas limit according to our needs. So in this particular case, you can see that we have a gas limit of 21,000 units limit. Sorry, so let me make it 42,000. Now as soon as I will double this, right, you will see the maximum fees, the fees that we are paying also get doubled. Okay, approximately double actually. And we have some other things also like max priority fees and max fees, which I'm not going to discuss in this course, but definitely I will share some resources where you can look for all these things in detail. Okay, now let me click on this save button. So now you can see that our estimated gas fees or our fees changed, right? And we can also, like, let me go for this, and we can also set it to low, medium and high. Okay, So you can see that in low we have to pay less amount of fees, but as we are selecting the less amount of fees, we have to wait for like 30 seconds for our transaction to be get mined. Whenever we are doing medium amount of fees, when we are selecting like a fees which is of medium amount, in that particular case we have to pay a fees of 0.00063 ether. And if I am selecting high, which is less than 15 second, means I want my transaction to be mined in less than 15 second, my money to, or not my money actually, my ether to reach to my friend in less than 15 second, like something like that. In that particular case you have to pay a fees of 0.0084 ether, which we also discussed in our previous video, right? Like the more the gas fees, the more your transaction will get mined faster, right? So now let me go back to our slide. I hope all these things are clear related to Ethereum gas limit, Ethereum gas price. Everything is now much clear, right? Now let us see one of the most important use of Ethereum gas limit. Now let's consider that this is an Ethereum network and A, B, C, E, F are the part of this Ethereum network. And someone has deployed this decentralized application or a smart contract on this Ethereum network. Now what will happen if this decentralized application, or let's say smart contract, consists of an infinite loop? Now who will stop this loop? Because according to the property of blockchain, blockchain is a distributed immutable ledger. It is immutable in nature. So if it is immutable in nature, then nobody can stop this decentralized application from running. And this decentralized application or smart contract will run infinitely on all the nodes of this Ethereum blockchain. And this is just an example. Just consider a situation in which in an Ethereum network thousands and lakhs of nodes are connected. So an infinite loop is running on all those nodes. So this will be a problematic situation. Now to prevent from this situation, this Ethereum gas limit is actually used. Now what I told you about Ethereum gas limit. Ethereum gas limit is the maximum amount of gas that a transaction can consume, right? So before deploying this decentralized application or smart contract, you have to tell that what is the maximum amount of Ethereum gas your contract or your smart contract is going to use. You have to set Ethereum gas limit before deploying your smart contract. So let's say you mention in your smart contract, okay, my smart contract or decentralized application is going to consume 40,000 units of Ethereum gas in the Ethereum gas limit field. So after 42,000 units is over, after that time, your decentralized application or your smart contract will get terminated. So in this particular case, Ethereum gas limit is, you can think, act as a barrier, right? Because if there is no such thing as Ethereum gas limit, then this contract will be running continuously or infinitely. But this Ethereum gas limit is actually putting some restriction on this smart contract or decentralized application. Okay, now your Ethereum gas is over, now you cannot run on these nodes, something like that. So this is how Ethereum gas limit can prevent us from infinite loop situations. Finally, our wait is over. Yes, finally our wait is over, and now we are going to begin with Solidity. So let's begin, and I hope you all are excited. So let's start. So what is Solidity? So Solidity is an object-oriented programming language which is used for implementing smart contracts. Yes, it is an object-oriented programming language. Like in our object-oriented programming language, we have classes, object, constructor, inheritance. In the same way, Solidity support all these features, and hence it is an object-oriented programming language. Solidity is a high-level statically typed programming language. Yes, it is a high-level statically typed programming language. Now, what do I mean by that? So by high level, I mean that Solidity resembles just like our human natural language. For example, when we talk about our C or when we talk about our Python, and if you want to print something, like if you want to print any statement like hello world, we do not have to write anything in the form of 0 or 1, which our machine understand or which our computer understand. What we do in C, we simply write printf, and when we talk about our Python, we simply write print, and we can do whatever we want by doing simply writing those statements, right? We do not have to write anything in the form of 0 and 1. In the same way, Solidity is a high-level programming language. So we do not have to write anything in the form of 0 and 1. We can simply write whatever we want to do simply in a human language, and we can do whatever we want to do in that manner only. And it is a statically typed programming language. Now, what do I mean by statically typed programming language? So statically typed programming languages are languages in which we have to tell the type of variable at compile time. Yes, we have to tell the data type of the variable at compile time. Like for example, if we talk about C, in C we have to tell that if we are declaring any variable like x, so we have to tell int x is equal to 5, and then semicolon, right? And but when we talk about a Python, it is not a statically typed programming language, so we can directly write x is equal to 5. So that's why in the same way, Solidity is also a statically typed programming language. We have to tell the data type. Like in C, we are telling, okay, int x is equal to 5. So we are telling that x is a variable which is of int type. In the same way, when we are declaring any variable in Solidity, we have to tell, okay, well, the variable that we are going to that we are actually declaring is of which type, is of which data type. Solidity is a case sensitive programming language. Yes, it is a case sensitive programming language. So what do I mean by this case sensitive programming languages? So case sensitive programming languages are languages which actually can distinguish between our uppercase as well as our lowercase. For example, if you are writing, for example, let's say you are writing human, okay, and you are using all the letters of human in capital, and then you are again using human, but you are using all the letters in this particular case in small letters, okay. So in both the cases, these two things are very much different for Solidity. Means human written in all capitals and human written in all small letters are very much different for Solidity, and we are going to see this when we are going to do our Solidity programming language, so don't worry. With Solidity, you can create contracts for such as voting, crowdfunding, blind auctions, multi-signature wallets. Yes, we can do a lot of things with Solidity, and Solidity is a very, very bright, means it has a very, very bright future. Yes, it has a very, very bright future. So Solidity can help you to do all these things. And when we are going to make our Solidity projects, then we will see some of these things also. And we will make some of these things. And yes, one important note that you should follow established development best practices when writing your smart contracts. Yes, because when we are talking about Solidity and we are talking about actually blockchain, right? And if we talk about blockchain, so blockchain is nothing but it is a distributed immutable ledger. And this property of immutable is definitely a blessing, but sometimes it can be like it can portray the role of a devil also. The reason is that once you write something on this blockchain, it can never be like erased, right? So in the same way, if you are writing some program and if that program is not written in a right way, then it can cost you millions. Yet it can cost you millions. And there are certain incidents in the past also where like company has had actually lost millions of dollars. So you have to be very much careful when we are using Solidity as a programming language. You have to follow the best practices, best development phases, best testing phases, so that you are writing a good Solidity program. Now we are going to talk about our Remix ID. Now we are going to use Remix ID for this course for compiling our Solidity projects. So we are going to understand how our Remix ID work in this particular video. So let's begin. Access our Remix ID, just type Remix ID on your Google search bar, then click on this first link. Now this is online version of your Remix ID. Like there are two versions of your Remix ID, like you can use it offline as well as online. And for this course we are going to use online version of Remix ID because we do not have to go for any installation or something like that. We can directly use Remix ID in our browser. We are going to use that. So this is how our Remix ID looks like. Just cross this out. Let me. Okay, now this is the area where we are going to write our Solidity code. This is the editor part, and there are so many options. Like for this option, we have a workspace option. We can choose any workspace we want. Like if you want for make a school workspace, then you can create a school workspace. If you want your college workspace, then you can create a college workspace. And in your workspace, you have various options. Like you can create file. Like if you want to create any file, then you can click on this option. Like for example, let me create a file and let me name this file as demo.sol. Now .sol is actually an extension for our Solidity programming language which we are going to use. Demo.sol. Here our file is open and we can type our Solidity code here. Now this is the option to create any new folder. Let's say if I want to create a new folder by the name, let's say demo only, demo. Okay, so by this I can create a new folder, and if I want to create a new file inside this folder, then I can right click on it. Okay, yeah, right click and new file, and then I can create a new file in, say I it demo1.sol. So this is how we create folders, files in our Remix ID. Now this is the option where we want to, if we want to use Git to publish our files, we use this option. And to upload files from our system, we use this option that is on your screen. Now, let us see one of the Solidity projects. Let's say go on this contract. Now, these are the folder that is actually provided by default by our Remix ID. So I have not created them. They are actually by default present when we open our Remix ID. So let's click on one of these contracts. This is how our our Solidity code looks like. Let me zoom out. So this is how our Solidity code looks like. And here are some important lines like XPDX license, which we have to mention the starting only, and we are going to discuss about it in upcoming videos. Then this is the Solidity version, and this Solidity version is actually like telling you like what type of like Solidity you are going, like Solidity version you are going to use. Like it is greater than 0.7.0 and less than 0.9.0. And if you are going to use any other version, like if you are going to use below version, then definitely it will give you an error. And definitely we have till now only till 0.9.0 only, so that's why we are using less than 0.9.0. Current version of Solidity is 0.8.7 while I'm making this video, so that's why it is less than 0.9.0. Okay. And when you will compile, now how we can compile this code? To compile this code, we have to click on this option, and here you will see all the options related to compilation. Now this is the thing where this like Remix ID provides you to select the Solidity compiler that you want to use. You can see there are various options. It has way a lot of options starting from 0.111 to 0.8.7. As I said, like currently when I'm making this video, 0.8.7 is the current version of Solidity. We can click on it, and then we can say want to compile. We will simply compile this, and our code is compiled. And this is the area where all the transactions are mentioned here. Me just will do up just a minute. Okay, yes, now so here is the place. If you will see, all the transactions are actually mentioned here, and we are going to see that when we are going to discuss about our Solidity programming language in detail. So all the options you will see here only. Let's say if I want to deploy a contract, okay, let's say I want to deploy a contract, then I will go to this option, and here are all the environment, and we are going to talk about these environment in detail in upcoming videos. Contract development deployment part, and this is the account. And for, if you will see, there are a lot of accounts, and we are going to use all of them. That do not worry if you are not seeing like what is all these things are, right? What is this 100 ether, what is this account? We are going to use everything of our Remix ID. So definitely you at the end of this course you will be like a pro, so don't worry about it. I'm just giving you a glance like how this all looks like. Gas limit, value, everything is present. And if this is an option for deploying our contract. Now if I will deploy, here you will see the transaction, right? This is the transaction that you are seeing. Green mark shows that okay, your deployment is successful, your transaction is successful. Okay, so I think you find it beautiful. I find it beautiful. When I studied first Solidity, I find this Remix ID very much cool. Okay, so I think this is it. This is how our Remix ID works. We have seen how the compilation process takes place. This is a compilation process. Here we compile our code, and how we know that our code is compiled when we have a printake on it. So I can compile the code by using Control plus S. Yes, we can compile the code by using Control plus S also. Now this is the area where deployment process takes place. We have a lot of different environment where we can deploy Web3 provider, and we are going to use them. We are going to make our Solidity project or Solidity smart contract. And yeah, this is how our Remix ID works. And how our Remix. So now we are going to see Solidity compilation process. And let me tell you, Solidity compilation process is very much different as compared to the compilation process of any other programming language. Because Solidity is a programming language which is used for writing smart contract for Ethereum blockchain, right? So its compilation process is very much different, and it is very important to understand how Solidity contracts actually get compiled. Okay, so let us start. Now let us say we have a source.sol file. Okay, we have a source.sol file, means this sol is an extension for our smart contract, our Solidity smart contract, and source is the name of our file. And when we give this file to our Solidity compiler, which is mainly Solc is a compiler for compiling our Solidity programming language. So when we give this file to our Solidity compiler, Then our compiler, our Solidity compiler, split this file into two parts, 1 and 2. And the first one is ABI and the second one is bytecode. And this bytecode is the one which actually get deployed to our Ethereum blockchain. Yes, so this bytecode is the one which actually get deployed to our Ethereum blockchain. So let us talk about our ABI first, and then we will talk about our bytecode. Now, what is this ABI? ABI stands for Application Binary Interface. This ABI actually helps another applications to communicate with our smart contract. Or in this case, source.sol file is our smart contract, right? Now, any other application, if want to contact with our source.sol file, then that application will be needing the ABI of our source.sol file. So this is what ABI is. So you can think ABI as a bridge between your smart contract and another applications which actually want to communicate with your source.sol file. Now, what is this bytecode? Now, this bytecode is the one which actually get deployed to your Ethereum blockchain. It consists of all the instructions which get executed on your Ethereum blockchain. So your source.sol file is not the one which actually getting deployed to your Ethereum blockchain, but the bytecode is the one which actually getting deployed to your Ethereum blockchain. And now let us see an example of both of our ABI and bytecode on our Remix ID. So let's go to our Remix ID. Okay, so we are on our Remix ID, and let me go to our contracts folder. In this, let me select one storage.sol. Okay, so this is our one storage.sol, and it has a number variable of uint 256 data type, and we are going to talk about the syntax and all these things later in our later videos, so don't worry about it. It has one function, actually two functions, one by the name of retrieve and another by the name of store. Okay, so let me go for compilation. Now, as soon as I will click on this compile one storage.sol, you will see that we will have two files here, ABI and bytecode. So let me compile it. Okay, and now we have two fields here, right? ABI and bytecode. So let me zoom in a little bit. You can see this is ABI and this is a bytecode. So let me copy it from here and let me paste it. This is just an online notepad. Okay, just a notepad. You can go on this website rapidtables.com and you will find it. The file that you're seeing on your screen, right? This is actually your bytecode. And this is actually your JSON format. And we have two keys here, object key and our opcodes key. Now this object key is consisting of your bytecode. This is your bytecode. The value that you are seeing on your screen, this highlighted in blue, is actually your bytecode. And this is actually your opcodes. Now what are opcodes? So opcodes are actually instructions. These are instructions which get executed on your EVM or your Ethereum blockchain. Okay, because our system do not understand high level language, right? And whatever we are writing here is actually a high level language, right? So this high level language get converted to a low level language, which is actually your bytecode, and this bytecode actually get converted to your opcodes. And we can see this also, right? We can see this also with the help of converter, bytecode to opcode converter. Let me copy this so that you can see how we can generate opcodes with the help of our bytecode. Let me copy it. Let me go to bytecode to opcode disassembler. Now this is a tool which is actually provided by your etherscan.io, and you can check this out also. And first of all, we have to write 0 and then into, because only accept hexadecimal numbers. Okay, that's it. So let me paste it here and let me decode. And now you will see that we have our opcodes, right? So decoded bytecode, push 080, push 01, push 10 into 40. So these are actually opcodes which we actually generated with the help of our bytecode. And you can see here, you can match all these values. First we have push 0804040. Let me click on this. You will see that push 080, push 040. Okay, so this opcode actually generated by your bytecode. Now let us talk about our ABI, that is our application binary interface. Let me copy it from here. Let me paste it. And now we have our ABI. And if you will see closely, you will see that we have our retrieve function here, that we actually have here also, retrieve. Then we have inputs like our internal type uint 256. This num means every variable and every function is actually you can see in our ABI, because if any other application want to communicate with our smart contract, then that application will be needing the ABI, and you can see why it is, because all these functions, all these variables are actually mentioned in your ABI, right? And we have one more function, right? That was store. So let us see whether we have it or not, and we have it, right? Store. We have this store function also mentioned in our API, and you can find a list of opcodes on your github.com. Just type github.com EVM opcodes and you'll find a list of opcodes here. Just click on this readme.md and you will see that we have a list of opcode available for our EVM, that is our Ethereum virtual machine. We have stop, add, multiplication, subtraction, means all those operations that we do in a high level form, like in our smart contract in a high level form, they get converted to our opcodes so that they actually get executed on our machines, because our machines only understand low level language, right? That's the reason we have these opcodes. We have a lot of opcodes because we do so many instructions, right? You can check this list also. Okay, so now let us summarize all the points that we have talked about till now, and let us see some of the new points also. So your contract bytecode is public and in readable form, means your contract bytecode need not to be in an encrypted form, because your bytecode is the one which actually getting executed on your Ethereum blockchain, right, on your EVM. And if you have your bytecode in an encrypted form, then it will be a time taking process, because then our EVM need to convert this encrypted to a decrypted form, right? Our bytecode need to be converted from our encrypted form to a decrypted form. So we do not want to do that because it will consume a lot of time. So that's why it is in readable form and it can be present in public. Contract doesn't have to be public, right? The contract doesn't need to be public. And if you're confused, like first you are saying that contract bytecode is public and now you're saying contract doesn't have to be public, like I'm not understanding it. Now let me remind you that your contract and contract bytecodes are two different things, right? You can generate your contract bytecode with the help of your contract, but you cannot reverse engineer or you cannot get your contract from your contract bytecode. Means you can go from here, but you cannot go from here to here. And we have seen this also, right? Like from our source.sol file, that source.sol file gets split into two parts, right? ABI and contract bytecode, right? So your contract bytecode and contract are two different things. So your contract doesn't need to be public, but most of the companies make it public so that transparency can be maintained and trust can be maintained in the eyes of public. So your contract, but it is not mandatory to have your contract to be public. But in case of bytecode, you can make it public because nobody can like go from your contract bytecode to generate your contract. So that's the thing. You can have your contract bytecode public, but your contract doesn't need to be public. But most of the country, as I said, make it public so that people have trust in the company. That's the thing. Bytecode is immutable. Yes, your bytecode is immutable. Once it is deployed on your Ethereum blockchain, you cannot change it. So the bytecode is immutable. ABI acts as a bridge between application and smart contract, right? We discussed this also. So your ABI is a bridge between different application, and the application means the application that want to contact or to communicate with your smart contract. Like if they want to like call a function, or if you want to access any variable, something like that. So they need the ABI of your smart contract. And we have seen that also, right? In our ABI, we have all the functions, all the variables mentioned in our ABI. So in any application that want to contact with our smart contract need this ABI. And the last point, ABI and bytecode cannot be generated with source code. Yeah, it is a very difficult task. So you can think that it is an impossible thing. You cannot generate your source code with the help of your ABI and bytecode. When we talk about Ethereum blockchain, we have two types of network. First is Mainnet and another is Testnet. Now, what is Mainnet? Mainnet, you can think of it as a network of Ethereum nodes which deals with real transactions. Transactions in which real Ether is involved. While Testnet is the network of Ethereum nodes which deals with fake Ethers, where the transactions are not of real value. And the main use of Testnet is to test your smart contract and decentralized application before deploying directly on your mainnet. For example, you created a decentralized application and now you want to test whether your decentralized application is working or not, so you can test it on your test network. And the reason for testing on the testnet is that you do not have to buy real ethers, so it is absolutely free of cost. So when we talk about mainnet, it is used for actual transaction with value. When we are talking about testnet, it is actually used for testing smart contracts and decentralized applications. Main network ID is 1 and test network ID is 3, 4 or 42. Now what is this? I am going to explain you with the help of a diagram. Just wait for a second. Now what is the example of mainnet? So Ethereum Mainnet is an example of Mainnet, while Testnet we have Rinkibi, Robsten, and there are other test network also. So now let us see what is this mainnet network ID is 1 and test network ID is 3, 4 or 42. Now this is the website where we can find the difference between main network ID is 1 and test network ID is 3, 4 or 42. Now what does that statement mean? We can see from here. This is a very good website. Want to learn more about test network and mainnet. You will come here. You will see that we have a very beautiful diagram. So what actually happened is that whenever you become a node, right? Whenever, let's say, you want to become a Ethereum node, in that particular case, you have two options. Either you can become a part of a main network or you can become a part of a test network. Now, if you select the network ID as 1, you become a part of a main network. This new node, and this new node selected an input parameter for network ID 1. So this node becomes a part of this main network. While if you select the network ID is 3, 4 or 42, you become a part of a test network. Now in this case, network ID equal to 3 is for Robson test network. Likewise, we have 4 or 42 for different test network. Like for Rinkibi, we have different network ID like that. So I hope this diagram is more than enough to explain you what is this main network and what is this test network. And we can also see this on our MetaMask wallet, and which we are going to talk about in detail in our upcoming videos. For now, let me open my MetaMask wallet. Let me input my password here. So here you can see that I have this much ether, right? I am not that rich, let me tell you. They're all fake ethers. Why? Because you can see that the test network that I have selected is a Robson test network. So these are all fake ethers. These ethers do not have any significance in real world. These are all for testing purposes. And I can also select Ethereum mainnet, and if I will select Ethereum mainnet, you can see I do not have any ether. So do not try to hack my computer or do not try to do anything with my MetaMask wallet, okay? I'm just telling you because you will find nothing. So this is, you can see in MetaMask we have different type of networks: Robson test network, Kevin test network, Rinkibi test network. All these are there just to test your smart contract, your decentralized application before deploying on your Ethereum mainnet. And on this etherscan.io, you can find all the latest blocks and all the latest transaction, and all these latest block and all these latest transaction are part of your main network. Okay, these are dealing with real ethers. And on this rinkibi.etherscan.io, you can see all the blocks and transaction which are actually happening on your test network, that is on your Rinkibi test network. That's why it is a Rinkibi testnet. So meet you soon in the next video. Bye-bye.
Thank you for watching this video till the end. We are working on a Web3 learning path where you get access to a lot of Solidity and Web3 courses, but with a twist, that is that these courses eventually help you become a great Web3 developer. One of these courses, the first course, is the Learn Solidity and Web3 Fundamentals blockchain of the preview which you saw in this video. Fantastic course to get started with Web3 and Solidity. If you want to continue your learning, check out the link in the description which gives you this full course, which is over 9 hours of content and practice and labs and projects. You can find the coupon code for a one-time purchase of this course with a heavy discount in the description, or you can subscribe to the codedamn monthly pro membership and get access to all the courses in this Web3 learning path and the main website in full stack as well for just a single subscription. Both the discounts link are in the description. You can go ahead and either subscribe to the platform for continuous learning, or you can buy this course one time at a heavy discount. You will not have to pay this price, where we have discounts for you for this special video. Make sure you check that out. That is all for this one. I'm gonna see you in the next video really soon. If you're still watching this video, make sure you comment down in the comment section, I watched this video till the end. Also, if you're not part of codedamm's Discord community, you're missing out a lot on events which we organize on a weekly basis to code. You already know the drill. Make sure you like the video, subscribe to the channel if you haven't already, and thank you so much for watching.